calculate A1. So let me give you a numerical example to demonstrate the very detail. Let's say this is example number 1. Suppose we consider the situation where the index k equal to 8, capital N equal to 16, which is 16 data point, and that can be expressed as 2 raised to the power 4, and that means R must be equal to 4. And let me assume that we want to compute the intermediate vector F2 corresponding to level 2. And for that vector F2, specifically we want to compute, let's say, F level 2 of the index k equal to 8. So we know there's a formula for F2 already, but we want to know for this one, okay, F2 equal to what? The formula say F2 of 8 should be equal to the previous vector, which is F1, at the same location 8 plus W raised to the power P times F1 at the location of the companion node. But what is the companion node of node 8? The companion node of node 8 should be equal to 8 plus a distance which is equal to n divided by 2 to the power L. Okay? So in this case, n is equal to 16, L is equal to 2, L equal to 2, so this will become 4, and therefore the whole thing become F1 of 12. Right? This whole thing, this parenthesis here is 12. So the formula say F2 correspond to k equal to 8 equal to F1 of 8 plus W raised to the power P times F1 of 12. Node 8 and node 12, they are companion node. Similarly, we can compute the value for F2 corresponding to the companion node, which is node 12. That equal to what? Well, that equal to F1 of 8. Instead of plus, it will be minus W raised to the power P again, and then multiply with F1 corresponding to the index 12. So you can see clearly the computation of F2 of 8 and the computation of F2 of the companion node, which is node 12. The formulas are nearly identical again. The only thing different is instead of plus, here you have minus. And you look at those two formulas, everything is known, because when you compute the vector at level 2, everything about level 1, the previous vector, is already known. The only thing we have to figure out is how do we figure out that power for P. So like in here, corresponding to k equal to 8, how do we find out the power P? Well, when k equal to 8, we can figure out the value for m based on the formula I told you earlier, k divided by 2 raised to the power r minus l. In this case, r is equal to 4 and l is level 2, and therefore the value m is equal to 2. So this one we know, corresponding to k equal to 8, m equal to 2. And then we copy the value of m equal to 2, you copy that into the variable j1 like I told you earlier. Okay, the next thing is we have to express this value m, which is equal to 2, using 4-bit binary form. So the first thing become, you remember this value has to be expressed like A4, A3, A2, A1. So how do we figure out, let's say, determine the bit A1? Okay, So the way it works is, computer program is, first we initialize the value p equal to 0. P is the unknown that you are talking here. P is the unknown. You assume p equal to 0. Then, after that, you take the initial value of m, which is the same thing as j1. You divide by 2. You see? You divide by 2. So j1 is equal to 2. Divide by 2. You get j1 equal to 1. Then, what you do after that, you take the value of 2 that you just calculated, you multiply by 2, and the answer you call jj2. Then after that, you take the difference between j1, which is the original value of m, you take the difference with jj2. So what is the answer? j1 is equal to 2, jj2 is equal to 2 also, because 1 times 2 is 2. So the difference is equal to 0. According to my previous slide, when the difference is equal to 0, that means you have to set the bit A1 equal to 0. If, on the other hand, for some reason, the difference is not equal to 0, then the bit A1 has to be set up equal to 1. Okay? So in this case, because the difference between J1 and JJ2, the difference is 0, so you have to set the bit A1 equal to 0. Okay. After that, what do? You figure out the new value of P, which is equal to the previous value of P times 2 plus the difference. Well, the previous value of P is equal to 0, because that is the one that you initialize from the beginning, you see? And then you times 2, and then you plus the difference, and the difference is also equal to 0. So that means the update value of P is still equal to 0. That's what we have so far.